analysis NCR, salt analysis NCRT. Um, we'll be discussing all of these tests and stuff. So first is detection of cation and an anion. So um, first we have anions. First is preliminary test with dilute sulfuric acid. So I'll be doing this in the form of the table itself. It'll be better. If you react your compound with what do you say, the sulfuric acid, you will get CO2, which turns lime water milky, and acidified KMnO4 stays pink. Sulfide turns, basically it forms H2S gas and turns lead acetate paper black. Colorless gas with pungent smell is released, which means it's SO2. SO2 turns acidified potassium dichromate green, and it turns lime water milky as well. Nitrite ion makes brown fumes, which turn potassium iodide solution containing starch solution blue. Basically, um, acidified potassium iodide solution containing starch solution. It makes it blue. That's an important one. Brown fumes which turn acidified potassium iodide solution containing starch solution blue. Colorless vapors, when it's acetate ion, the blue litmus is turned red. Smell of vinegar is released. So disappear of milkiness in carbonate ion is if you keep passing the gas, and yeah. Then sulfide test, we know one of them is sodium nitroprusside, because from POC we have done sodium nitroprusside test which turns violet. Okay, to make the what do you say, the sodium carbonate extract or sodium sulfate. Like, you need Na2S to form the test, right? To form the sodium nitroprusside test. So for that we take sodium carbonate extract to form Na2S. There we took sodium metal and reacted with your organic compound. Sulfite, we use BaCl2 solution to form BaSO3. Basically, sulfite may we use these stuff. I told you, right? Sulfur dioxide also turns lime water milky, and this is the preliminary test actually of nitrite. So when you add it to dilute H2SO4, basically that's the preliminary test, right? Dilute sulfuric acid. So you'll get what do you say? This thing, blue color appears when you add Ki and starch solution for nitrite ion. Nitrite ion, blue color with starch solution, blue color. Okay, blue color with starch and Ki solution, and yeah, 1 ml of water extract with your. I mean, you don't need to know 1 ml and stuff. We just need to add sulfonylic acid and 2 to 3 drops of 1 naphthalamine. Then we'll form red color. Okay, I'll show you the reactions. First confirmatory test for acetate is ester test. Ester test. After that, we have neutral ferric chloride solution, which forms this salt FeOH twice and COO minus, like this. Okay, it forms. This is a neutral compound. Therefore, Fe is in 3 plus, and this has been asked in a PYQ actually. From here, you can say that lime water is CaOH twice. If it's passed in excess, you form CaHCO3 twice, which is colorless. We told you, right? When you pass CO2 in excess, it forms calcium hydrogen carbonate. Yeah, so this one, lead sulfide test. First, you get your sulfide. Then, when you react it with H2SO4, you give H2S. Then, after that, it's made into the sodium extract by passing it to Na2CO3, right? And then you get the sodium extract. Then you get you pass it through lead acetate solution to get black precipitate. Okay, lead acetate solution to get black precipitate of lead sulfide. Okay, that is also PYQ. Basically, next test is Na2S with sodium nitroprusside forms a complex of purple color. Oxidation state of Fe in this compound is +3. So Na2FeCN5NO gives Na4FeCN5NOS. Then Potassium dichromate paper, I mean, this we know, right? Sulfite ion, SO3 minus, turns it into green color, which is a chromium sulfate. I told you, right? There are three chromium salts which are green in color, which is given in the Math on Go PDF. Barium sulfite is the test for BaCl2 we add to your sodium carbonate extract of the salt. So sodium, basically, if you want to react it in any ionic mechanism like BaCl2, any double displacement reaction, you have to create a sodium carbonate. You have to react it with sodium carbonate. Like the gas released here is SO3, right? So basically, it'll be like kind of you'll form Na2SO3 because of SO3 minus ions present. Precipitate of sulfite decolorizes acidified potassium permanganate. Okay, so basically, like the SO3 minus ion forms a white precipitate of barium sulfide, and it also turns potassium dichromate paper green. It makes it decolorizes potassium permanganate from pink to colorless, like that. Nitrite ion, I told you already. First, it produces nitrogen gas, which is brown, and nitrite ion can also be tested for reacting with acetic acid to form HNO2, and then it reacts with Ki and starch solution. Like, I mean, reacts with Ki to give I2, and I2 turns starch solution into blue color. So the flow of control of nitrate. So compound plus H2SO4, you pass it through Ki and CS3COH, it liberates I2. I2 turns starch solution into blue color. And here what releases is HNO2. In Gris Ilosway test, which is your sulfonylic acid with naphthylamine. So first what happens? So sulfonylic acid plus water extract with acetic acid. Basically, it forms HNO2. Then your what do you say? It forms a diazotization. Basically, diazotization reaction occurs in this molecule because first you add sulfonylic acid, then HNO2 and your CS3CO minus attaches over here and forms a diazotization. Diazotization occurs, and diazotization does what do you say, the addition over here, para addition, para electrophilic aromatic substitution over here, and forms your red azodie. So first you have sulfonic acid, then water extract with acetic acid forms HNO2, basically HNO2, sorry, HNO2 over here, and then it forms the diazonium salt. Um, Diazotization salt with one naphthylamine forms red azodide, and this is all because of HNO2 formation. So HNO2 formation can help in two things for NO2. The test solution should be very dilute. Now, upon passing through neutral FeCl3, it forms this compound and then it decomposes. So in both cases, so in this intermediate or the complex, Fe is in plus 3 state, and in this one as well, Fe is in plus 3 oxidation state. And this complex decomposes on heating and addition of water to form iron 3 dihydroxy acetate. Okay, so you form acetate ion with Fe plus and water, it forms this, then it decomposes. Then conc H2SO4 is common sense. It releases chlorine, bromine, iodine, nitrate, and oxalate. Okay. Chlorine, pungent smell, ammonium hydroxide, dense white. Bromine, reddish brown gas, solid MnO2, it increases the reddishness. And the solution acquires red in color. I2, violet vapors which turn starch paper blue, and a layer of violet sublimate is formed on the side of the tubes. Okay, it becomes dense with adding MnO2. So you add MnO2 in both, it will become dense. Then nitrate ion turns brown fumes which evolve become dense upon heating. Okay, upon addition of copper turnings, and the solution acquires blue color. Then oxalate, you have CO and CO2. Basically, oxalate, it basically turns lime water milky because it releases both CO and CO2, and gas coming out of lime water burns with a blue flame. So I hope preliminary test is fine. Now confirmatory. So this reaction we should know, white fumes. Then MnO2, say if we react it, it'll give Cl2, which is greenish yellow pungent gas. So this we have learned in 10th grade as well. MnO2 plus NaCl gives Cl2. Like that, salt solution acidified with dilute HNO3 on addition of silver nitrate solution gives a curdy white precipitate, that we know. And then it's soluble in excess ammonium hydroxide to give diamine silver 1 chloride. So yeah, then we have a chromyl chloride test. Salt plus K2Cr2O7 plus H2SO4 gives your chromyl chloride. Chromyl chloride is red in color, I think. Basically, sorry, it's yellow solution, not red solution. And then after that, chromyl chloride with NaOH gives Na2CrO4. Na2CrO4, and Na2CrO4 is, what do you say? Yeah, basically is that. One second. Sorry, guys. Yeah, it's red. I got confused because the language in NCRT, that's on me. Basically, chromyl chloride is a red solution, red vapors. Red vapors on passing with NaOH, you get Na2CrO4, which is your yellow solution, not a precipitate. Then PbCrO4. Okay, PbCrO4 that is formed, that is yellow precipitate, and that comes from CH3CO2Pb. Okay, acetate, lead acetate plus sodium chromate. So next reaction that came in 2026 JE mains is K2CrO4 plus H2O2 gives chromium pentoxide. Chromium chromium pentoxide dissolves in amyl alcohol to give blue color. That is also P by Q. Bromine vapors turn starch paper yellow. So the next part is basically NaBr plus Cl2 gives NaCl plus Br2. Br2 is orange brown. How you form NaBr? Same thing, sodium carbonate extract. So how do you find this Cl2? It's not just available. You have to create it from chloroform or carbon tetrachloride. Then we know AgBr is pale yellow. For AgCl, it's white, like that. Iodide ion, we know it is turning starch solution into blue complex. And yeah, then these reactions, right? These reactions, they have come in Allen's score tests. So NaI plus H2SO4 can give Na2SO4, NaHSO4, Na2SO4, and Na2SO4, but it can give different side products. Like basically, H2SO4 in different concentrations act as a um, what do you say, oxidizing agent. So for example, sulfur dioxide, hydrogen sulfide, sulfur, they are formed as a result. So SO2s, then H2s, like that. Okay, MnO2 to the reaction mixture, violet vapors become dense because it is causing release of I2. So MnO2, what does it cause? Release of the gases. Okay, and same test can be conducted for I2. It's the same as Br2. Cl, Br, I are brothers. Basically, Cl obviously you can't perform this test, but yeah, this is also obvious. I'll be skipping it. Nitrate ion also has a test, which is your brown ring test. Brown ring test, you add FeSO4, and I'll go step by step. Nitrate ion with H2SO4 gives HSO4, okay, and gives HNO3. Now that is your key agent here. So nitrate ion with any H2SO4 gives HNO3. Then FeSO4, H2SO4, HNO3 gives Fe2SO4 thrice and an NO. Now FeSO4 NO combines to give nitrosoferrous sulfate. So the flow of control I'll be writing. So from this reaction, we can get to know that FeNOSO4, okay, nitrosoferrous sulfate, it is brown in color. Now we have oxalate ion. Oxalate ion, it releases both CO and CO2, which is known, and it forms calcium oxalate with CaCl2, which is also known white precipitate. Then you have calcium sulfate formation with H2SO4, and you can pass this through KMNO4. This pink color of KMNO4 is discharged, meaning KMNO4 Mn is from plus 7 and it's going to Mn is from, right now it is at 2 plus. So it's being discharged. So KMNO4 is discharged because H2C2O4 is getting oxidized into CO2. This balanced reaction is very important. Then you finally the last group of this thing, sulfate and phosphate. So first we did dilute H2SO4, then conc H2SO4, and conducted these certain tests. The ions involved are, for dilute we have, what do you say, CO2, sorry, CO3 minus, acetate CH3COO minus, we have NO2 minus, and we have SO3 minus, I think. Yup, SO3 minus, and we have S2 minus. All those corresponding tests, we know SO3, say we know it is BaSO3 type, and S2 minus is your lead acetate. So that is for the group 1. Now we give group 2, which is addition of H2SO4, which is fine. And then, yeah, that's all. And we know all of these tests now. I mean, hopefully. Now we can move on to group 3, which is your phosphate, sulfate, all that. So first we have BaSO4 formation. Like there's no, it's only confirmatory test for these, right? BaSO4 formation indicates that it has SO4 2 minus, and lead acetate, which is also, sorry, lead sulfate is also white. And you can test for phosphate by using ammonium molybdate solution. Ammonium molybdate solution to this test solution containing phosphate ions, yellow coloration or canary yellow precipitate of ammonium phosphomolybdate is formed. So Na2HPO4 plus 12 and NH42MO4 plus 23 HNO3 gives a canary yellow precipitate. So for this video, only anions are being covered because this is a huge chapter and there's so many reactions to go through. So yeah.